Hi everyone! Today let's work on more exercise in chapter 3. Let's look at example 1. Use Venn diagram to verify the following. So first, part A, the complements of A complement union B complements equals A intersects B. So let's see. So we draw the Venn diagram and we have A and B. So first, let's look at A complement union B complement. So A complement is outside of A. And B complement is outside of B. So when we take the union is everything outside of this region. Okay, so this is A complement union B complement. When we take the complement of that, it becomes this middle guy. So this is A complement union B, and then another complement. And this is exactly A intersect B. So we know this is exactly A intersect B. So this is how we use the Venn diagram to verify this equality. Okay, part B. Okay, so first of all, we want to have A intersects B complement. Well, A intersect B complement means it's in A but not in B, so which is right here. So let's say this is A and B, and this is A and not in B, right? Okay, and then what's next? We want to look at the complement of this guy. So we have everything outside of this, like a moon. Okay, so this is A intersect B complement. And then on the right hand side, okay, let's figure out what is the right hand side. So when you want to show the equality, you can start with your left hand side and figure out, okay, what it looks like until you reach the right hand side. Or maybe you can start with your left hand side and get to some points, and then also draw your right hand side and see what get to some points. Let's see, those two regions are the same. Okay, so the right hand side, A complement, so outside of A. Union B. What is B? B is this piece. When we take the union, well, that is exactly this, right? Outside of this moon. Okay, so they are equal. Okay, so this is A complement union B. So that's why they are equal. And do you remember we talked about the De Morgan's law? So De Morgan's law. So A intersect B complements. So we talk about like complements is really like the negative numbers. So the negative numbers kind of flip the inequality sign. So this complement also flip the intersection and union. So that's why when we try to distribute, we have A complement and it was intersection, now become union, B complement. So it's kind of like you distribute the complement sign, but when you see the intersection and union, you kind of switch them. Okay, so A and A union B complement is A complement intersects B complement. Okay, so this is the De Morgan's law. Now, how do you verify whether these equations are, those two expressions are equal? So you can use this De Morgan's law, right? So you start on the left. Okay, so when you try to distribute the complements, when you see union, it becomes intersection. And the complement is really like the negative, the two negative numbers. So negative negative become positive, right? So that's why complement is just A. So that's why we have A intersects B. That is exactly the right hand side. And then for part B, when you try to distribute the complements, intersection become union. And then B complement is they kind of cancel, so we just get B. So that's why you see they're the same. So this is how you think without drawing the Venn diagram. Okay, so maybe in the exam, I ask you a true or false questions. I give you two expressions and say they are equal. Then you can use this way to figure out quickly whether they are equal. Right? So this is example 1. Let's continue and look at example 2. Given probability of A is 0.35, probability of B is 0.4, probability of A and B is 0.2. Find the following. Part A, probability of A or B. Okay, so let's draw some picture here. So we have A right here, B right here. Okay, so how do we find probability of A or B? Well, the general addition rule, this is probability of A plus probability of B minus probability of A and B. So this is 0.35 plus 0.4 minus 0.2, which is 0.35 plus 0.2, 0.55. Okay? So before you work on these examples, feel free to stop the video and work on the example first. After you've finished, continue to play the video and check your answers. Okay? Alright, part B. Probability of A complements in B. A complements in B means this is the region in B but not in A. So it's just this guy. Right? And what is this guy? Because we already know P of B and we also know their intersection. So this guy is just P of B minus P of A and B. Okay, so P of B is 0.4, P of A and B is 0.2. So the answer is 0.2. Okay, part C. P of A and B complement. A and B complement means is in A, but not in B. So that's why it's P of A minus P of A and B, right? P of A is 0.35, P of A and B is 0.2, so we get 0.15. Do you have the same answers? Part D, P of A complement and B complement. Okay, so A complement and B complement means is outside of A and outside of B. Okay, so which means it's the outer region. U1 minus the union. Okay, probability of the union is 0.55. So that's why this is 0.45. So far, so good, everyone. Okay. Alright, so part E. Are A and B independent? Okay, so how do we check whether they are independent or not? Well, we want to check whether P of A and B equals P of A times P of B. So this is what we want to check. P of A and B is 0.2. P of A is 0.35. P of B is 0.4. Are they equal? No. Right? So they're not equal, so that's why A and B are dependent. They're not independent, so they are dependent. So far, so good, everyone. Let's continue. Example 3. If A and B are dependent, P of A is 0.45, P of B is 0.3. Find the following. Okay, because they are independent, P of A and B is just P of A times P of B. Okay, so guys, be careful. A and B are independent, and A and B are disjoint. These two concepts are not the same. They're disjoint. Okay, so A, B are disjoint. It means A and B is empty. So that's why probability of A and B is empty. Okay? Sorry. 0. Okay, it is P of the empty set, so it's 0. Okay, but when we say A, B are independent, usually in general, P of A and B is not 0. Okay, so it equals P of A times P of B. In this case, 0.45 times 0.3. And let's see, 0.45 times 0.3. 0.135. Now you can see this guy is not equal to 0. Okay? And then part B, P of A given B. Well, part B, P of A given B, what is that? Well, by the definition of conditional probability, that's probability of A and B given P of B. Well, P of A and B by part A, this is 0.135. P of B is 0.3. So let's see. So we can use answer divided by 0.3. And let's see. Divided by. So 0.135 divided by 0.3. 0.45. Oh, you know what? Because they are A and B are independent. Okay, so if we know A and B are independent, then P of A given B is equal to P of A. So we don't care about whether B occurs or not. The probability of A stay the same. Okay, so that's why this guy equals P of A. Alright, and then part C. Part C, P of A or B. Well, again, general addition rule is P of A plus P of B minus P of A and B. So P of A is 0.45, P of B 0.3, P of A and B is 0.135. Okay, so put this in our calculator. Let's see. Okay, let me move this down a little bit. 0.45 plus 0.3 minus 0.135. So 0.615. Okay, so this is part C. How about part D? P of A complement and B complement. Again, by the De Morgan's law, this is the complement of A union B, so, which is part C. So that is why this is 1 minus 0.615. And the answer is 0.385. Right? Okay, so actually there is another way to compute that. Okay, because A and B are independent, then P of A complement and B complements. So A complements and B complements are also independent. Okay, if A, B are independent, their complements are also independent. So this guy is P of A complement times P of B complements. P of A complement is 1 minus P of A, which is 0.45. P of B complement, 1 minus 0.3, so 0.5 0.55 times 0.7. Let's see. Do we have the same answer? Yes. See? 0.385. We get the same answer. So here I teach you 2 ways to compute part D. Alright. So far so good, everyone. Okay, let's continue. So example 4 is about Bayer's theorem. A desk lamp produced by the Luminar company was found to be defective. There are 3 factories, 1, 2, 3, where such desk lamps were manufactured. A quality control manager is responsible for investigating the source of the found defect. This is what the quality control manager knows about the company's desk lamp production and the possible source of the defect. So here we have factory 1, 2, 3. The percentage of total productions is right here. And you can see when we add them up, it's 1. Okay? And the probability of defective lamps is right here. If a randomly selected lamp is defective, what is the probability that the lamps were manufactured in factory 3? Okay, so let's say A is the lamp is defective, okay. And then we have 3 companies. So let's say B1 is company 1, B2 is company 2, B3, 3 factories. So let's say B1 is factory 1, B2 is factory 2, B3 is factory 3. Okay, now let's see. So first of all, let's compute P of A. Okay, probability of defective. This is the potato rule. Remember, we cut the potato into slices. And here we have 3 regions, B1, B2, B3. And then the potato, right, A is right here. So we cut it into 3 slices. Okay, so it's PA and B1 plus PA and B2 plus PA and B3. Alright, so the first one is P of B1 times P of A given B1. Remember the multiplication rule? We can also call reference rule. By the way, this name just made by me. Okay, so we can eat banana first, and after we eat banana, we eat apple, right? And then next, we have P of B2 and then P of A given B2. P of B3 times P of A given B3. Alright, what is this? P of B1. So B1, 0.35. So 0.35. Probability of defect, 0.015. P of B2, also 0.35. P of A given B2, 0.01. P of B3, 0.3. P of A given B3, 0.02. Alright, so plug this in our calculator. 0.35 times 0.015 plus 0.35 times 0.01 plus 0.3 times 0.02. So the answer is 0.01475. So this is P of A. And then, so what's the probability that the lamp was manufactured in factory 3? So this is asking, now we know the lamp is defective, what's the probability that this is manufactured in factory 3? So B3 given A. by the conditional probability, we know this is P of B3 and A over P of A. And what is P, B3 and A? Well, that is exactly right here. Yes? So right here. So right here. So just copy down here. Over P of A, which is 0.01475. Okay, now this is 0.3 times 0.002 divided by 0.01475. And the answer is 0.4068. We round up, okay? 4068. Okay, so this is the probability. Alright, let me ask you a question. Okay, so more questions. If a randomly select lamp, okay, so if a randomly selected lamp is not defective, what is the probability that the lamp was manufactured, was made in factory 2? Okay, so then this questions, we given that the lamp is not defective, so given A complement, not defective. What is the probability that the lamp was made in factory 2? So factory 2 is B2. So this problem is asking us this. Then what is this? This is P of B2 and A complements over P of A complements. Well, the numerator also breakfast rule. Okay, so we can do B2 first and then P of A complement given B2. Denominator, P of A complement is 1 minus P of A. Okay, let's see. P of B2. P of B2 is 0.35. P of A complement given B2. Okay, so given B2, the P of A given B2 is 0.01. Then P of A complement given B2 is going to be 1 minus 0.01. And then 1 minus P of A, which is 0.01475. So what is this? Okay, let's see. We have 0.35. And times 1 minus 0.01 is 0.99 divided by 1 minus 0.1475. Okay, is that good? Yes. So the answer is 0.351 round up 7. 3517. So this is the answer. Okay. All right. Do you have the same answers? Yes. Good. Let's continue. Example 5. Bowl A contains 2 red chips. Bowl B contains 2 white chips. And bowl C contains 1 red chip and 1 white chip. A bowl is selected at random, and 1 chip is taken at random from that bowl. Part A, what is the probability of selecting a white chip? Okay, so this is like the Bayes theorem, and well, here bowl A, bowl B, bowl C is like our B1, B2, B3, right? And then the white chip is like the A. Okay, so here let's call them different names, right? So our usually A, now we call it W, stand for white chip. Okay, the chip we pick is white. Okay, and then B1, B2, B3 is like, now we call them A is, the chip is from bowl A. B, the chip is from bowl B. And C, the chip is from bowl C. Okay, but A, B, C are like the B1, B2, B3. So if we have to draw the picture, this is A, B, C. They are mutually exclusive, so pairwise disjoint. And W is like the potato. So we cut it into slices. What is the probability of selecting a white chip? So P of W is P of W and A plus P of W and B plus P of W and C. Okay, W and A, which one do first? We need to pick the bowl first, and then after we have the bowl, then we can ask what's the probability of picking a white chip from that bowl. And here P of B times P of W given B. Here we have P of C times P of W given C. P of A, because now we have 3 bowls and they are equally likely to be picked. So that's why P of A is just 1/3. And in bowl A contains 2 red chips, so the probability of getting a right chip is 0. Bowl B, probability of bowl B is 1/3. It contains 2 right chips, so the probability of getting a right chip is always, so times 1. And probability of bowl C is 1/3. And probability of getting a right chip, because bowl C has 1 red chip and 1 right chip, so we get half. You get 50 chance to pick out the right chip. So that's why, what is this? This is 1/3 plus 1/6, and the answer is 3/6, which is 1/2. And it kind of makes sense because the 3 bowls, they are equally likely to be picked, and each bowl contains 2 chips. And so that's why total we have 6 chips, and 3 of them are white. So that's why we get 50% chance of getting a right chip. Okay, so part B. If the selected chip is white, what is the probability that the other chip in the bowl is red? Okay, what does that mean? So it means given that the chip we select is white, what is the probability the other chip is in the bowl is red? Well, which bowl is it? The bowl has a red chip and a white chip, so this is bowl C. So it's really asking, okay, if we select a white chip, what is the probability that this chip is come from bowl C? Okay, so that's why by the conditional probabilities, this is P of C and W over P of W. C and W, what is that? Right here, right here, right here. So this is 1/6. P of W is 1/2. Alright, so 1/3. So the answer is 1/3. So far, so good, everyone. Okay, very good. Alright, so let's see. This is example 5. You can also ask, okay, what is P of B given W? And this is P of B and W over P of W. P of B and W will be this guy, right? So 1/3 over 1/2. This is like 1/3 times 2, so 2/3. And realize P of A given W is 0. Why is that? Because bowl A has 2 red chips. It does not have white chips. So the probability that the white chip comes from bowl A is 0. And you can see when we add them all up, it equals 1. So the white chip either comes from the bowl B or bowl C. Okay, everyone? So let's continue in video part B. See you soon!